Solving radical equations is similar to solving equations with rational exponents. Let's look at number 1. Remember that inside of the radical we have an exponent. If there is no exponent, it's an invisible 1, and if there is no number on the outside of the radical, it is an invisible 2. And we can rewrite this radical as a rational expression, or as an equation with rational exponents. So our base here would be x, our numerator would be 1, and our denominator would be the 2. And that would be equal to 5. So it's saying now we have a rational exponent, and we can take the inverse by multiplying by 2 to both sides of the equation. So this 1 will cancel out this 1, and this 2 will cancel out this 2, and we're left with 5 squared, which is 25. So x will be equal to 25. We could check our work by substituting the 25 in for this x. Right? Does the square root of 25 equal 5? Yes, it does. So that checks. For number 2, we have an invisible 1. This time they have a 3 on the outside of the radical, so it's going to be the cube root. And we have x to the exponent 1/3 equals 7. We take the reciprocal of 1/3, or sorry, inverse of 1/3, which is 3 over 1. And we get x equals 7 cubed, or 7 times 7 times 7, which is 7 times 7, 49. 49 times 7 is 343. See if that checks by substituting 343 into the x, and the cube root of 343 is 7. The last one that we'll do in this lesson is number 12. What we want to do is we want to isolate the radical on the left side of the equation. So that means we first need to move the 2 and the 3. So if we subtract 2 from both sides, we're left with 3 times the square root of t minus 4 equals 27. From here, it's 3 times the square root, so we're going to do the inverse of multiplication and divide by 3 to both sides of the equation. And we're left with the square root of t minus 4 equals 27 divided by 3 is 9. So from here, we can solve it like we did the last problems. So since there is no number outside of the radical, it's an invisible 2. And since there is no exponent inside of the radical, it is an invisible 1. So we can rewrite the radical as t minus 4 to the exponent 1/2. And that is equal to 9. If we take the reciprocal of the inverse of 1/2, it's going to be 2. So this 2 cancels with this 2, the 1's cancel with each other, and 9 squared is 81, and we're left with just t minus 4. If we add 4 to both sides, we get t equals 85. We can check to see if that works by substituting 85 in for t. And we have 2 plus 3 times the square root of 85 minus 4. Does that equal 29? Well, 85 minus 4 is 81. So we have 2 plus 3 times the square root of 81, which is 9. Does that equal 29? 3 times 9 is 27. 27 plus 2 is 29. So that checks. And our solution is t equals 85.